Hello there guys, and welcome back to another epic inexorable maths video. So in this video we're going to be looking at differentiating the square root of x from first principles. So this is an exam style question if you're an A-level maths student, or there's plenty of other exams out there and maybe you just want to know how to do it out of curiosity. But we're going to be using the formula for differentiation from first principles, which is in the yellow box. So the derivative of a function is defined to be the limit as h approaches 0 of f of x plus h minus f of x divided by h. So as always, the first thing that we're going to do is simply plug into the function. So the derivative of the square root of x will be the limit as h approaches 0 of, and this is actually where some people make mistakes here. What do you actually plug in? So I'm going to do a quick aside here, and I'm going to write down, again, f of x is the square root of x. Now what plenty of people do, and this tends to be in my experience, the most common mistake actually in this topic, is that they don't know what to put for f of x plus h. So what do you think f of x plus h will be in this question? Because plenty of people will make a mistake and say that it's the square root of x on its own and then plus h afterwards. This is not right, this is wrong. And it's wrong because that would be f of x close bracket plus h. That would be f of x and then plus h. But this is f of x plus h, which means all of the x's need to be replaced with x plus h's. And if I replace x in this function with x plus h, then I'll be taking the square root of the entire thing. So f of x plus h here will be the square root of all of x plus h. The h is also inside the square root, okay? Right, so we're going to have the square root of x plus h minus the original function, which is just the square root of x, divided by h. Okay, lovely. Now, what can we do from here? It's not very obvious, okay? It's not very obvious. Now, some people, they could also make the mistake of thinking that perhaps you can rewrite the square root of x plus h as the square root of x plus the square root of h, but no, you cannot do that. You cannot do that. Does not work. So what can we do? Well, we have to be a bit clever. That's why this is a slightly harder question than some of the basic ones. What I'm going to do, and this is not immediately obvious, but when you think about it, what else would you be able to do? What I'm going to do is I'm going to rewrite this, okay, which I'm doing right now, and I'm going to multiply this by another fraction. And of course the fraction should essentially be the number 1, so it needs to be the same on the numerator as it is on the denominator, but the question is, what will it be? Well, I'm going to try to simplify it. So what I should really be doing here is multiplying by something that would maybe get rid of some square roots at least somewhere. It's worth a try. And so I'm going to multiply by the square root of x plus h plus the square root of x. Divided by, of course, it would have to be the same thing. Otherwise, we wouldn't be multiplying by 1 and it wouldn't be equal. Okay? And why have I done this? Well, it's because on the numerator of the fraction, we now have the difference of two squares. And well, hopefully, I'm alleging that this will actually do something, but let's see how it goes. So if we multiply this all out, we'll have the square root of x plus h times the square root of x plus h, which is x plus h. And then doing the outside, so this one here and this one here, we will have the square root of x times the square root of x plus h, so plus root x plus h. And then I'm going to do the inside functions. And so that's just going to be the negative of what we just had there, so minus the square root of x times the square root of x plus h. And finally, if I do the last functions, I'll have minus the square root of x times the positive version of the square root of x, which would just give me minus x. And you can see that quite a lot of stuff here will cancel out, which is exactly what we wanted to happen. And of course, we have to do the denominator too. The denominator will just be h times the square root of x plus h times the square root of x. Now let's get to cancelling. This is the satisfying part. So of course we have an x, and then later we subtract it. As I mentioned earlier, I'm going to do this in a different colour so it's really clear what's cancelling. This function here, or this term, and this term will also cancel. And so actually the numerator simplifies very, very nicely. And what we're going to have is almost everything cancels. Okay? So this is equal to the limit as h approaches 0 of, and then what is left on the numerator? Just h. And I'm going to write this. H root x plus h root x. And of course you can see that if we now divide the numerator and denominator by h, we will get 1 over the square root of x plus h plus the square root of x. And this is really good because we can now let h be the number 0 without dividing by 0. Lovely. And so this is just equal to 1 over the square root of x plus 0. So in other words, just 1 over the square root of x plus the square root of x again. And that's 1 over 2 times the square root of x. And this can also be written as 1/2 times x to the power of minus 1/2. Okay. Now let's do a quick sanity check, as I like to call it. Make sure that we're definitely correct about that. Well, if we use the normal power rule for differentiation, we'll find that the square root of x, remember that the square root of x is the same thing as x to the power of 1/2. If I differentiate x to the power of 1/2 using the power rule, times by the power, take 1 off the power, I'll have 1/2 x to the power of minus 1/2. And do you see that that is actually the exact same thing as what we have worked out the answer to be? So we know that we did it right. So the final result is that the derivative of the square root of x is, and I'm going to leave it with square roots because I think it's nicer, is 1 over 2 times the square root of x. Or in other words, 1/2 x to the minus 1/2. And guys, that's really all there is to it. So thank you so much for watching. I highly appreciate it. And I will see you in the next epic Inexorable Maths video. Cheers.